about sensible heat of water and also latent heat of vaporization HFG, and at the same time the total heat H. Generally we represent the total heat by H. So today we will discuss about total heat at different points in this TH diagram. You just look at the screen. This diagram is for temperature and enthalpy. So enthalpy is total heat. Okay, if you look at the diagram, then this T naught is, we call it 0 degree centigrade, but it is more appropriate to say the freezing point of water or melting point of ice. But the thing is that the freezing point of water at different temps are almost same, 0 degree. There are very little difference in freezing point. So generally at atmospheric pressure the freezing point is 0 degree centigrade, boiling point is 100 degree centigrade, but at higher pressure also boiling point changes, but freezing point generally there is very little change in freezing point or melting point of ice. So that is why we may also call it 0 degree centigrade always, but it is more appropriate to say that it is the freezing point of water is T naught. And what is Ts? It is the boiling point of water, or we can say the saturation temperature of water. Saturation temperature of water. And T sup is the temperature of superheated steam. So T naught is freezing point of water. And what is Ts? Ts boiling point of water or saturation temperature of water, and T sup temperature of superheated steam. And suppose a point 1. Where is the point 1? T1. Where is the temperature T1? T1 is the temperature of water at point A. So where is the point located? It is not the saturation temperature Ts, or not the freezing point of water also. It is in between O and B. That means this is not saturation temperature of water and not the freezing point of water. In between we consider one point A and temperature is T1. Okay. Now we are trying to define the term total heat. What is total heat? Whenever we say total heat, it is calculated from freezing point of water or melting point of ice. Same thing. From which point we measure total heat? From point O in this TH diagram, or we can say from freezing point of water. Then the point may be anything. It may be point A, it may be point B, C, D or E. So total heat at point B is, what does it mean? That means amount of heat required to increase that to reach that point from from freezing point of water, which is generally 0 degree centigrade. So total heat is clear for you, or it is also called the enthalpy. What enthalpy? Total enthalpy. We will say total enthalpy or simply enthalpy. Now we will discuss this thing. Now we want to find out the total heat at point B, and that we represent by H. That is what, if we want to define what is total heat of water at point B, amount of heat required to raise the temperature of water from freezing point to the boiling point. Amount of heat required. So in the TH diagram, it is from this point to this point. That means OB, small b, in the x-axis. That means enthalpy axis. So that will represent the total heat. So this heat is also called the sensible heat of water, HF, okay, that we have discussed earlier. Then this amount of heat is called sensible heat of water and represented by HF. So at point B, H is equal to HF. At what point? At point B. And what is the point B? The B is the saturated liquid. Last class we discussed that saturated liquid is point B, and from point B if we go towards the right side, then it will be the vaporization, vapor and water mixture. Now we want to find out the total heat of water at point D. At point D, okay? And it is better to say steam, but we can say water also, but it is better to say steam because this is steam, not water. So at point D, it is 100% steam. X equal to 1, dryness fraction X is equal to 1. Now we will say amount of heat required till the point D from freezing point of water, and in this diagram if you see, that is equal to from this point to this point OD, right from the freezing point. That will be called total heat. So total heat of water or steam is different depending upon the condition at which the steam is or at which the water is. Accordingly, the total heat will be different. Now this at point D, if it is point D, that means dry steam, this is also called the enthalpy of dry saturated steam, and it is represented by Hg. So at point D, it is Hg. Total heat of water, total heat of dry steam, or you can say enthalpy of dry saturated steam. Fine. So last class we got Hg is equal to Hf plus Hfg. Now Hf is what? Saturated liquid, total heat of saturated liquid, and Hfg is what? Latent heat of water, and that is equal to what? B to D. This person is Hfg and this first person is Hf. But point D is x equal to 1 and point B is x equal to 0. That means at point B 100% water, this is 100% steam. So that is why it is Hfg from B to C. So Hg is total heat of what? Dry saturated steam. So till now it is okay. Till now we get what is Hf, what is Hfg, that is the latent heat person, and also we have come to know what is Hg. The amount of heat required from point B to D is called the latent heat of vaporization, Hfg. Just now we have explained this. Now point B is the saturated water. Point B is what? Saturated water at temperature Ts. This point is at temperature Ts, and at the same time point D is also saturated dry steam but at temperature Ts. Now you see, total heat of water at point A is the amount of heat required to increase the temperature of water at freezing point to water at temperature T1. So we have discussed what is point B, point D. Now we come to point A. I have mentioned that point A is in between B and O. It is neither saturation temperature nor freezing temperature. So what is the total heat of water at point A? So what is total heat from freezing point? So temperature is T1. So if we say total heat is HA, A is for the point SA, we can write simple H also. Total heat is equal to what? This is generally represented by HFL. F stands for fluid, FL stands for fluid. That means this is in liquid state. But if we write HF, then it represents total sensible heat up to point B. But since it is below B, we will call it HFL. That means below saturation temperature. And for that we know that formula was mCp dt, because what is heat? H2 minus H1 is equal to, can you remember, mCp T2 minus T1. Can you remember this? Yes. So, yes, change in enthalpy is mCp T2 minus T1. Now, what is this? This HA means H2 minus H1 actually. Now, m is the mass, but in this case, we consider it is always 1 kg. For per kg of steam or per kg of water we are considering. Now, what is Cp here? Cp is specific heat of water. Since this is water, this is not air or gas. Specific heat of water at constant pressure. That is Cp. W also we can write Cpw, but we write only Cp. Now dt is change in temperature. So this will be mCp dt minus dt. M is 1. So what will be this? Cp, and T1 is how much? So T1 is T1. But if it is T not equal to 0, then it will be equal to Cp T1. Why 0? Generally, the freezing point of water is 0. Pressure may be different, but it is almost always equal to 0. Now, value of Cp is 4.2 kilojoule per kg per Kelvin. This you have to remember. Value of Cp, specific heat of water, is 4.2 kilojoule per kg per Kelvin. So, if the temperature is say 300 Kelvin, then what will be the value of H? Equal to 4.2 multiplied by this Kelvin. It will be ultimately, it will become kilojoule per kg, because the Kelvin will cancel. Per kg, this mass of heat is the amount of heat. Now total heat of steam at point C. Okay, now we come to point C. Now we can see point C is located in the region vapor plus gas, vapor plus water, liquid vapor mixture. So point C is wet steam. This is wet steam. And suppose the dryness fraction is F. dF, dryness fraction is F. Now what does it mean? Dryness fraction is X. That means out of 1 kg, X kg is dry steam, and 1 minus X kg is water particles or water, same thing. Is it clear for you? Dryness fraction X is actually what? Fraction of dry steam present in the wet steam. And if X is the fraction of dry steam, total is 1. So 1 minus X is the fraction of water. The rest is water. Anyway, so if we know from this to this, what is the amount of heat from this point to this point? B to D?
HFG.
Good. H, F, C. In that case, we can say at this it is X equal to 0, and at this point this is X equal to 1. So HFG means 1 into HFG. If it goes up to point this, then it is 1 into HFG. But if it is at this point, this will be equal to X into HFC. So HFG for 1 kg of steam, 1 kg of dry steam, it is HFG. But if in 1 kg of wet steam, X kg is dry steam, then it will be X into HFG. Okay, that we will discuss. Now what will be the total heat? From diagram you can see total heat at point C is equal to OC. What is the point O? This is O and this is C. So this is equal to what? This plus this. So that is HF plus BC. Now what is BC? It is not HFG, but part of the HFG. So what will be equal to how much? Now what will be this? This is equal to HF plus X into HFG. So I think this is clear for you. H at point C. Buji paisa etu? Dryness fraction X howa karone total heat at point C is HF plus X fraction into total latent heat. Okay? So some say the point is not C.
Sir.
Yes. Qua.
Sir, BD is equal to HFG asil no?
Uh,
Sir, BD is equal to HFG asile.
BD is equal to HFG. Yes.
Sir, তাহলে sir BC equal to X into HFG কেন কি হবে sir?
Because C is X of 1. X part of 1. HFG is what? 100% of HFG. Then if you reach D, that is 100%. But if you are going to the X percentage, then that is X percent of 100%. What is 100%? HFG. Now X percent means percentage. If you take it simply X fraction X of HFG, and that is equal to X HFG. তাৰমানে চোৱা শিৱমে কৈছা না শিৱম হয় না নহয় তুমি চোৱা at point B what is the HFG কিমান হ'ব latent heat কিমান হ'ব point B
Sir, 0.
HFG equal to 0. So at point B তুমি চোৱা at point B X is X into HFG. So what is X? 0 into HFG. It is 0 হল না? সেবাম বুঝি পালা? এতিয়া পয়েন্ট তুমি এটোত আহা পয়েন্ট D কিমান X equal to 1. Now D যদি হয় তোমাৰ H equal to কিমান হ'ব HF plus X into HFG. So that is equal to HG. ঠিক আছে?
Yes, sir.
ঠিক আছে, good. So that way you can calculate the thing. Now we will again consider the point E. Now come to the point E. And where is the point E located? Kot ase? Kuntu regionot ase? Liquidot ase ne liquid vaporot ase ne dry regionot ase? Dry. Yes. Dry means it is beyond dry, that is superheated regionot ase. So tumi jodi soa ami total heat hol air para air loike. So air loike to ami already jano what is this up to this point this is Hg. Only thing we have to add this amount of heat. And during this time the temperature increases and this temperature is T sub and it increases from Ts. Okay? Then what is T sub then? T sub is equal to, from diagram you can see OE equal to OD plus DE. Okay? OD plus DE. And OD is already Hg. And DE we can write like this. M mass of steam, then it will be 1. T C sub. What is C sub? Specific heat of superheated steam. That is C sub. CP sub you can write also. CP sub, this is also okay. CP of superheated steam into DT, temperature difference. And this will be equal to 1 CP sub T sub minus Ts. And this is the amount of heat for superheated steam. Hg plus this. Now this person, it has a special name. This temperature difference is called degree of superheat. That means how much superheated? T sup minus Ts. That much is the amount of superheat. Or we can say degree of superheat. Now if we consider m c sup and this much, that is actually this is heat. So it is called heat of superheat. We say it is superheated, but we have to say how much superheat. That means what is the heat added beyond dry steam? That is heat of superheat. Dry steam plus heat of superheat is total heat of superheated steam. Okay, so today we have discussed what? Enthalpy, or we can say total heat at different conditions of the steam. We have discussed the enthalpy or total heat of wet steam. What is this? H is total heat is equal to HF plus X HFG, where X is dryness fraction of wet steam. We have also discussed enthalpy of dry saturated steam, which is total heat is H and that is equal to Hg and that is equal to Hf plus Hfg. That means X equal to 1. We have also discussed enthalpy of saturated water. That means saturated water means at saturated temperature, and that is equal to total heat is how much? Equal to the sensible heat of water. Sensible part, HF, saturated water, point B in our previous diagram. We have also discussed enthalpy of superheated steam, and that is equal to H is equal to Hg plus Cp sup, actually Cp sup T sup minus Ts for superheated steam. We have also discussed enthalpy of water below saturation temperature. If it is below saturation temperature, say temperature is Ts1. Now I give the name Ts1. Then H equal to how much? H equal to M is 1. M will not put. Cp, M will be there, but I will cancel it. This is 1. Cp into Ts1 minus T naught. That is the enthalpy of water below saturation temperature, point A in our previous diagram. And this is generally, it is 0. So H is equal to Cp Ts1. What is Ts1? Better to say T1 itself. It's okay, Ts1, temperature of water below saturation temperature. Okay? Any question till now? Now someone tell me what is the definition of specific volume. Anybody? Volume unit. Yes? Volume per unit mass. Very good. So volume per unit mass is called specific volume. Now if we reciprocate it, mass per unit volume, then it is equal to what? This is actually density. So specific volume is the reciprocal of density, mass per unit volume. Now specific volume of dry steam is generally represented by Vg, because for dry steam we use the letter G, gas, like Hg. So specific volume of dry steam is Vg. Now you just tell me, initially we take 1 kg of water 1 kg, mass is 1 kg, and there is a fixed pressure, pressure is fixed. Now this volume we can know, this volume is Vf. For water it is called Vf, okay? Fluid. And if we heat it to Vg, volume will definitely increase. Now you know already, you are aware of this. Now if it become Vg, that means dry saturated steam, then the volume will become Vg. Okay. Now which volume is more, Vf or Vg? Pressure is same, Vg. So Vg is much greater than Vf, because Vf is, we know how much volume will be occupied by water, we know that how much volume will be occupied by the same mass, that means 1 kg will remain 1 kg, but the steam, it will become steam, and steam, what type of steam? Dry steam, that become Vg, okay? Because everything is taking place at constant pressure, we are keeping the pressure constant. Similarly, for wet steam, it is represented by VW, say wet, okay? V wet, specific volume of wet steam. And for superheated sheet, we can represent it by V sup. So Vg, it is a fixed some value at particular pressure. So now for wet steam, that means wet steam means there is a fraction called dryness fraction. And what is X? X means X is dry steam. X part is dry steam, and what is the rest? 1 minus X is actually water. Water particles means this is water. So what will be the specific volume of wet steam? Specific volume of water is Vf, okay? That I have shown over here. Now what will be the specific volume of wet steam? You see, first we consider the dry part. What is the dry part? X. So it is X into Vc. Now next volume, what is the wet part? Water, and that will be 1 minus X, and this is Vf. Okay, and generally we consider it approximately equal to XVg, because we can neglect this quantity. That is why I have written Vg is much greater than Vf. So we'll, for all practical purposes, we'll consider that Vf is less, not less, but compared to Vg it is very less, and definitely 1 minus X is also a small quantity, because if X equal to 0.9, then 1 minus X equal to again 0.1. So 0.1 is already a small quantity, fraction, and multiplied by another small quantity, it will be even smaller. So that is why we neglect this quantity, and for our practical purposes we take it as XVg. What is this? Specific volume of wet steam, where X is the dryness fraction of the wet steam. Okay. Another thing we know, G stands for gas or dry steam. So this is, steam is perfect, steam behaves like a perfect gas when it is dry steam. So this is dry steam. So what does it mean? This is a perfect gas. That means ideal gas. It will obey the gas law. And definitely superheated steam is also behaves like a perfect gas. Steam is also a perfect gas. Now you apply the gas law for these two conditions. What condition? Dry steam and superheated steam. What is that this? We have got P1 V1 by T1 equal to P2 V2 by T2. But today we will not consider P1 V1. we'll raise PG Vg by Tg, that means dry steam, equal to P soup V soup divided by T soup, superheated. Now Pg and P soup is constant because everything is under constant pressure. Now what remains? Vg by Tg equal to Vg by T soup. So from this we can find out one relation. And what will be that relation? You can tell me. So V soup is equal to how much? T soup Tg into Vg. So from this relation we can find out specific volume of superheated steam.